we're going to be working with the slope formula to find the slope of a line. If you're given 2 points, you can find the slope of the line by using this formula. Now again, the slope is made up of the rise over the run. And the rise is our y values, and the run is our x values. So you'll be given 2 points, or you can choose 2 points on a line and find the slope for that line. And the first point is labeled x1, y1. The second point is x2, y2, indicating that they're 2 separate points. Now, key note here is, if we have an x2 minus an x1 equal to 0, then our slope is undefined, because you can never have 0 in the denominator, or you can't divide by 0. So if we get 0 in the denominator here, we end up with an undefined slope. So now, when we're trying to find the slope of the line and we're given 2 points, we're going to be using the slope formula. Now the slope formula, what I like to do when I'm given 2 points is label my x1, y1 and my x2, y2, so that I don't reuse a value. And I'm going to take that information and I'm going to substitute it into the formula and evaluate. So I'm going to substitute this information in, and be careful because it's always minus. It's y2 minus y1, it's x2 minus x1. So when you have a minus as one of the values and it's plugged in, you're going to see you might get a double negative, and that double negative will turn to a positive. So you see here I substituted in x2, which is 7, minus the x1, which is a -3. That's creating that double negative. And then my y2 is a -2, and my y1 is 4. So now I'm going to do the evaluation, the arithmetic here, and that double negative is going to change to a plus, so I'm going to end up getting a -6 over +10. So now I have the slope of the line, and whenever you're given a slope that is a fraction that can be reduced, you have to reduce the fraction. If you do not reduce the fraction, the slope will be, or the answer will be incorrect, because it always wants it in reduced form. So the slope here, in this case, would be a -3 over 5. So always remember to reduce if you have to. Pause and try. So again, I like to label my points, and it doesn't matter which one's the x1, y1, x2, y2 of the points, but you have to make sure that the x1 is the x position in the order pair, and the y1 is the y position in the order pair. And now you're going to take that information and substitute it into the formula, and you should have gotten 2 over 2, and that will simplify to 1. So we don't end up with a fraction for this slope, we end up with a whole number, 1. So now we're going to be writing equations of the line. And when we write equations of the line, there's a couple equations of the line that are very simple if you know these certain rules. The first one is, if you're given a point and it's going to be some x value, some y value, a number, it's going to be an x value, a y value, and you're given that the slope is 0. Now what you need to know is when the slope is 0, it is a horizontal line, and when you have a horizontal line, the equation of the line is y equals, and it's going to be y equals whatever the y value is. So if we have a slope is equal to 0, to write the equation of the line, it's going to be y equals, and you're going to look for the y value, and that's what goes into the y value spot. Now, if you have the slope is undefined, remember when the slope is undefined, it is a vertical line, and when you have a vertical line, the equation of the line is x equals whatever the x value is in the order pair. So these are a couple quick notes that write equations easily just by knowing these rules. And then also, if you're given the y-intercept and you're given the slope, you can write the equation of the line using the information that's given. Now remember, when you're given the y-intercept, 0 is the x value. we know we have the y-intercept if we have 0 for x. So that's a key note. If you have an ordered pair and there's a 0 in the x spot, then you have the y-intercept. If you're given the y-intercept and the slope and you're asked to write the equation of the line, you'll take the slope that's given, you'll plug it in to the m value in the y equals mx plus b, and then you'll take the y value in the ordered pair and substitute it into the b. And it only works when we're given the y-intercept and our x value is 0. So when you have the x value 0, we have the intercept, we can plug in the y value for the b, and we plug in the slope. Now remember, you always have to have the x variable in the y equals mx plus b. So let's see what this one would look like. So if I'm asked to write the equation of the line with the slope -3/2 and the y-intercept is 0, 5, I have my y-intercept and I have the slope. And I'm going to plug it into the y equals mx plus b. So I'm taking the slope, I'm taking the y value in the ordered pair, and that's going to be my b, my intercept. And all I'm going to do to write the equation with this information is substitute it into the m and the b, and I have my equation of the line. So this equation of the line, when the slope is a -3/2 and the ordered pair is 0, 5, my equation would equal y equals a -3/2 x plus b. So this is the equation of a line given the slope and the y-intercept. Pause and try. So you have the y-intercept and you have a slope, so your equation of the line would be y equals 3/4 x plus 4. Pause and try. So remember, when the slope is 0, it's going to be y equals whatever the y value is, and in this case my y value is a -1. So the equation of the line for when the slope is 0 is y equals a -1. Pause and try. So when the slope is undefined, it's x equals whatever the x value is in the ordered pair. So the x value in the ordered pair is 12. So the solution or the equation of the line would be x equals 12. So now when you're not given the 3 scenarios we just worked with, and you're given a point and a slope, or the slope and a point, you can use the point-slope form to find the equation of the line. And how it works is you're going to take the slope and plug it into the m of the formula, and you're going to take the points that you're given, the x1, y1, and substitute it into the x1 of the formula and the y1 of the formula, and then you're going to solve for y. So let's see what this looks like. So we're asked to write the equation of the line in slope-intercept form that contains the point 3, -5 and the slope 2/3. So now I'm asked to write the equation of the line. I always check, do I have the intercept, the y-intercept, and I don't, because in the x spot I don't have a 0. And then I check, is my slope 0 or undefined? And it is not. So therefore I have to use the point slope form to find the equation of the line. So the next thing I'm going to do is take the information and plug it into the point slope form. Now again, my point is made up of x and y, so my x1 is going to be the 3 and my y1 is going to be that -5. And I'm going to put the slope, the 2/3, into my m. So I substitute everything in, and again you're going to leave that y as is, and you're going to leave that x inside the parentheses as is, and substitute in the m, the x1, and the y1. Now that you have it substitute in, you're going to have to solve for y. So now when you're solving for y, you have to notice that when you have a -y1, you're going to have a double negative, and that's going to change to a plus. So you end up with y plus 5, and then you're going to have to do the distributive property. So you have to do the distributive property in order to solve for y, and you have a fraction on the outside. So when I distribute that 2/3 to x, I'm going to end up with 2/3 x. But be careful, when you distribute that 2/3 to that -3, it's a fraction times a whole number. So 2/3 times a -3, you could put that -3 over 1, simplify and multiply across. So notice that the 2/3 times 3 over 1, the 3's would cancel and you'd be left with 2. So you end up with a -2. So that's where that's coming from. And now you still need to solve for y, so you need to get y by itself, which means you have to move that plus 5 over to the other side of the equal sign, and to move it, you're going to do the opposite, which is subtract. And you can subtract it from the constant, that -2, and then you'll have your equation of the line. So the equation of the line, when a point with a point 3 comma -5 that has a slope 2/3, you end up with y equals 2/3 x minus 7. Pause and try. So again, you're substituting it into the point slope form, and we end up with y minus 2 equals 1/9 parentheses x minus 9. You're going to do the distributive property. Keep in mind you have 1/9 times 9, which is going to turn to a 1. And then you're going to solve for y. You add 2 over. So the equation of the line here would be y equals 1/9 x plus 1. Pause and try. So again, you could use the point slope form here, but remember, when the slope is 0, it's simply y equals and whatever the y value is in the point. So in this case, the solution or the equation is y equals 5. Pause and try. So you have to know the rule here. When the slope is undefined, it's x equals whatever the x value is, and in this case the x value is 6, so the equation of the line is x equals 6. So now when you're asked to write an equation of a line that passes through 2 points in the slope-intercept form, well, remember, you need to know the slope in order to write an equation of a line. So if you're given 2 points, you're going to have to first find the slope by using the slope formula. So the first thing when you're given 2 points is find the slope. Use the slope formula to find the slope. So we're going to plug in the information that we're given, and we're going to find the slope, and we find that our slope is going to be a -2. So now that we have our slope, you can choose any of the points. Whatever point you choose, you're going to end up with the same equation. I always just choose the first point. You can choose the second, and you'll get the same equation. And you're going to use the point slope form to find the equation of the line. So I'm going to use the slope that I found, and I'm going to choose the first slope, or the first point, and I'm going to substitute it into the point slope form. So I get y minus 5 equals, and then the -2, that's the slope I found, times x minus 1. And now I'm going to solve for y, the distributive property, and then I'm going to get y by itself by adding 5, and I have my equation of the line that passes through 1, 5, and 4, -1. So in order to write an equation of a line, you're going to need the slope. If you're given 2 points, you're going to have to use the slope formula to find the slope first, and then you choose either point to find the equation of the line using the point slope form. Pause and try. So the first thing I'm doing is finding my slope. I found it to be a -2. I'm going to substitute it into the point slope form, and I'm using the first point. You could have used the second. And then I'm going to solve for y, and I'm going to get my equation of the line is going to be y equals a negative 2x plus 11. So now when we're talking about parallel lines have the same slope. Parallel lines have the same slope, but their intercepts are different, because if their intercepts aren't different, then we have the same equation. So parallel lines, the coefficient of x is the same, but the constants are different. So when you're asked to write an equation of the line that is parallel to a given equation, and this equation y equals 4x minus 2, and passes through a certain point, and in this case it's 1, negative 5, if they're telling us that the lines are going to be parallel to each other, and you need to write an equation of a line, you need to understand that when you write an equation of a line, you need to have a slope and at least one point. Now, when you're told that the line's parallel to a given equation, well, what you need out of the equation is the slope. So you're going to identify what the slope is, and you don't care about anything else in that equation. So you identify the slope. Now you have the slope you need and the point that's given, and you can write the equation of the line. So when they say it's parallel, from a given equation, take the slope, and the slope is the coefficient of x. Use that slope and the point that's given and plug it into the point-slope form. Plug it into the point-slope form and then solve for y. So I substituted in. I'm going to solve for y by doing the distributive property, and then I'm going to subtract 5, and I get my equation of the line. So y equals 4x minus 9 is parallel to the given line y equals 4x minus 2. So again, when they're parallel, they have the same slope. You take the slope from the given equation and use the point, and then plug it into the point-slope form to find the equation of a line that's parallel. Pause and try. So all you need here is the slope from that equation, which is 1/2, and you're taking the point and you're substituting it into the point-slope form, and you're solving. So again, be careful here. When I do the distributive property of 1/2 times 6, well, that's going to end up being 3. And then I'm going to solve for y. I get my parallel equation is y equals 1/2 x plus 2. So now when we're talking about equations of the line that is parallel, and you're given a y equals 7 and passes through a point 1,4, well, what you need to know is, what is the slope of y equals 7, or y equals a number? Well, when we have y equals just a number, that means that I have a horizontal line, and when I have a horizontal line, the slope is 0. And if we're talking about parallel, then the slope is 0, and when the slope is 0, the equation of the line is going to be y equals whatever the y value is in the order pair. So the y value in this order pair is 4, so my equation of the line that would be parallel to y equals 7 would be y equals 4. So when you have parallel and it's a y equals, it's going to be a y equals equation, and whatever the y value is in the given order pair. Pause and try. So be careful here, because we have x equals a negative 5, which means my slope is undefined, and when the slope is undefined, we are having an x equal equation, or a vertical line. So x equals 3 is the equation of the line that would be parallel to x equals a negative 5 passing through the point 3, 2. When we talk about perpendicular lines have slopes that are opposite reciprocals. Now remember, a reciprocal to a fraction is you flip it. So if you're given a whole number, you would put it over 1 and flip it. And then you change the sign. It's going to be opposite signs. So there's two things you need to do to the slope in order for it to be perpendicular. And that is to get the reciprocal and change the sign. So you're asked to write the equation of the line that is perpendicular to y equals a negative 3x plus 5 that passes through the point 6, 7. So when you see the word perpendicular and you're given an equation of the line, you want to take that slope that's in that equation, and that's all you need from that equation is the slope. And then you need to get the opposite reciprocal of that slope. So we have a negative 3, and the opposite reciprocal would be 1/3, and it's a positive 1/3 because it's a negative 3, so it has to be the opposite sign, which is positive, and then when you put 3 over 1 and flip it, you get 1/3. So this is the perpendicular slope for this equation, and now I'm going to use this slope and that point 6, 7 in the point slope form to find the equation of the line that would be perpendicular. So you're going to substitute it into the point slope form and you're going to solve for y. So be careful here, 1/3 times 6 will give you 2 when you do that distributive property. And then you add 7 over and you get the perpendicular line would be y equals 1/3 x plus 5. So be careful when you're doing perpendicular because you're going to have to take the slope and get its opposite reciprocal from the given equation. Pause and try. So the slope here, perpendicular, would be a positive 2, and then you'll use the point slope form. Be careful of those double negatives because that x value is negative 2. That's going to change that to a plus. And then you'll do the distributive property and solve for y, and you get the perpendicular line would be y equals 2x plus 11. So if you're given the equation of the line is perpendicular to y equals 7 and passes through a point 1,4, be careful here because remember, perpendicular means I have opposite reciprocal slopes. Well, the slope of the line for y equals 7, the slope is equal to 0. So I have the slope is 0. Well, I need the perpendicular slope. So keep this in mind. If the slope is equal to 0 and I want the perpendicular slope, if I put that 0 over 1 and change the sign to negative and flip it, I'm going to have a 0 in the denominator. And that means that the slope is undefined. So the opposite reciprocal of 0 is undefined. So when we have perpendicular lines and we have a y equals, then we're going to end up having an undefined slope for the perpendicular equation. An undefined slope means that I have an x equals equation. So the perpendicular equation for y equals 7 would be x equals 1, the x value in the order pair. So be careful when you have perpendicular that you do the opposite reciprocal and you end up getting x equals. And in this case, the order pair has 1, so it's x equals 1. Pause and try. So we're looking for a perpendicular line to x equals 5, so we end up getting y equals 10 because perpendicular is the opposite of undefined, which would be 0, opposite reciprocal.